A very good afternoon to everyone on the call. I myself, I head the asset operations department within the organization. I'm coming from EDP, Energy de Portugal Renewables, which is an MNC. But we operate our APAC countries as a hub in Singapore. The challenge statement here is to derive a solution, or we are sharing our problems for a data-driven, low water usage solar panel cleaning solutions. I think majority of us are familiar with solar panels. They are usually located on rooftops. It could be in high-rise building, low-rise building, or it could even be a ground-mounted solar farm, or even could be a floating solar farm. So where our Let me see. Okay. So more details on the challenge statement is that the current situation is that, for example, at least for Singapore, we have about 3,000 solar sites. Some of them are very visible, some of them are not so visible. So like I mentioned, it's spread across rooftop, floating, and also ground-mounted solar farms. So the current regime, it's that once the project is the development stage is over, the construction stage is over, and then the project have be handed over to us, the asset operations function. And we will have to maintain and operate the asset for a very long duration. Usually solar have a lifespan about 35 years, but contracts we see maximum going up to 25 years. So it's a very long-term operations and maintenance requirement. So what do we have in place is an annual fixed schedule solar panel cleaning regime. So what do we do is that we engage, we have our own internal resources. We also engage vendors to come on board to actually do panel cleaning. So they actually put up a water hose up to the roof, and then they use the tools like semi-automated brushes or even robotic tools to do panel cleaning. So what do we see as a problem, or what do we want to see as a solution is that we want to have more like a data-driven approach, because we have seen inconsistent performance improvement between assets. Because why do we clean the panels is to get rid of the soiling, but soiling differs, or the environmental aspect of each site differs time to time. So we need a more data-driven approach. So this can lead the current regime can lead us to wasting OPEX. That means we have more operational costs, high water usage, heavy reliance on manpower, because we are putting the resources on the roof working for almost the whole day. That also brings us to safety exposure for work at height. And we also see some assets that has access challenges. That means maybe it doesn't have a cat ladder, or the roof already been worn out. So this also create more challenges across high-rise building, and limited scalability, because it's very manpower driven. So for us to scale to deploying more megawatts, it's going to be a bit more tougher. So why is it a critical issue? Cleaning is a single largest O&M cost driver, at least for the distributed generation. Singapore rooftop sites are unique. It has complex access, height restriction, and at times limited water points. Annual cleaning is not optimized for real soiling. It's purely time-based. So sustainability demands water reduction, and at the same time, manpower cost is increasing. So what do we see as requirement? So we have list couple of guiding requirements. So core requirements that cleaning must be or recommended. I would say waterless or extremely low water solution. It should be data driven, so it only triggers when required. Safe to work at height if there's a deployment of manpower, and should be scalable to easy to deploy. Must work across all the different types of solar installations like rooftop, floating, and ground mounted. Technical requirement, we are trying to achieve about 2 to 3% performance uplift post cleaning, or any solutions that's provided. To also achieve about 70% at least water reduction. Ideally, it will be 100%. Then it's for also low energy consumption. So if we have a solution that is solar battery powered, will be preferred. And if there's a product that need to be used, it must be lightweight, because at times we see solutions that is quite robust and it exceeds the roof structural limit, or I can't even put the machine or the tool on top of the panels. And the ability to cover at least about half a megawatt of rooftop within an hour for large rooftop or long blocks. Operational consideration that we are looking at is must be able to integrate smoothly with the existing O&M workflow. So vendor must ensure reliable support, minimal additional maintenance, safe deployment procedures. So we need to be very cautious about the safety aspects. Must be adaptable to different building types, because at times, even though we have different solar types, building types also matters, because we have a very large fleet of assets on top of public housing. And we have quite a number of commercial industrial clients. So they are particular on how a solution can affect their existing waterproofing condition, existing roof condition. And lastly is also to have minimal disruption on the ongoing site operations. So all in all, I would just say that we have few thousand rooftops. We are required to clean the panels every year. Currently, it's very manually clean, very resource driven. It's not data driven because we have been doing a very routine 1 year once cleaning. So we want to go out of this problem and find an alternative solution where eventually you are more data driven. At the same time, there's aspect of innovation, not undermining the safety aspect. Yeah. So that's overall the presentation. So last part, which is the pilot plan and what we are open to support and stuff. So we can work on trial. So we are open for a location. So we can open up a HDB rooftop, a CNI rooftop, or even our floating system. So duration is usually about 3 to 6 months for us to see the pre-cleaning performance and post-cleaning performance. So, like I earlier mentioned, the scope should have some sort of level of soiling detection. So you are able to do a data-driven trigger on when is the panel cleaning required, because it doesn't have to be maybe once a year, maybe it's once every 2 years, or maybe certain sites you need to do 2 times a year. Then our next scope is cleaning and treatment, if anything is required, performance measurement, and OPEX reduction assessment. So these are the whole scope that we see in the trial. We list some success criteria. I think I earlier mentioned almost the same thing. Resource EDPR will provide. We will give you the sites for testing. We will give you the historical performance, historical cleaning regime data. We will also give you some manpower support. We have our own team, so that is not an issue. Funding support can be discussed. Monitoring team support for performance analytics, this also can be done. So we can actually furnish the site of data, and also for the access to the operating environments if you want to have any more site surveys. Yeah. So that's it from me.
Okay. I think it's pretty clear. It's not an easy one because there are quite a few things to manage there, but that's the point of having a challenge like this. And I think it is important, as you've mentioned a number of times during your presentation, that there are essentially two parts. There's the data side of this that can trigger when there should be a cleaning, and I think that's really important, developing, a condition basis recommendations. Now's the time to clean. And then there's the actual cleaning. So those on the call, some of you may be looking at this from, well, we're going to be better actually at the data side and anticipating and predicting when the clean should be, versus those of you who are actually in the robotic side of activities or some other solution that you might be looking at, or you want to do the whole thing. Here we go. Jackson, thank you. I was waiting for you to jump in and I saw the robotics there. So let's take those. Jaffa, can you see them clearly? I don't
Yeah,
need to read them to
I
you.
do. I
Great.
do, I do. I do see it clearly. Yeah. So just to reiterate the point that you have just shared. So it's actually, if you want to look at it, there's two problems.
Yeah,
But there could be two solutions or it could be one solution or
yeah,
so. So we are actually open on that. Okay.
sure.
To address to Jackson's question, what is the tilt angle of the solar panels? So we try not to have a very extreme tilt. So at times we follow the roof profile. So usually there's about 3 to 4 degrees tilt. But if we are looking at that's for metal roof installation, but for ground mounted and also reinforced concrete installation, we at times we even see about close to 10% tilt. So that is the tilt aspect. What is the general size of the solar panels that need to be cleaned? Today, because we have been installing solar since for almost 13 years in Singapore. So the technology has advanced and there's a lot of new versions of panels, but majority of the latest version is approximately about 2 meter by 1 meter. And usually they are stacked in a table or a array where it's all in close proximity. So if you are from a robotics front, a robot actually can run on the panels. And there are actually solution providers that are actually providing similar solutions. What is the maximum weight? The robot to ensure there's no risk or micro cracks on the panels. Particularly, this is not focus from the panels aspect. The panels itself has a minimum weight load stress that they can take, but it's more of the structure that's beneath the panel, how the panels is being mounted. So project to project specific, I think we have different value that is allowed to be placed on the panel. But typically, robots with the weight about less than 50 kilograms can actually run on the panel. And that's a read tested, but because the panel manufacturers do not give us any guarantees on this. Yeah. So I hope I answered your question. So I see another question. Monitoring by detecting cleaning analytics. How are they being cleaned now? Time sensitive data. Today, cleaning is done on a very routine manner. So if I do it in January this year, next year, January, we revisit the site. But it's not done on a data-driven approach. So if we can have the entire Singapore map put into a data and we can identify which are the areas that have higher soiling, that means higher particles in the air, which are the areas that's prone to have new roads or new constructions. And then we have analytics to say that this site requires more cleaning, or at the same time, it's able to absorb information of performance data. So once you see the rating performance, that means the solar resources is constant. We have the same
yeah.
sun around the Singapore, but when we see certain projects having a derating, so from that aspect, we can actually also conclude some data-driven.
Okay.
Yeah,
We've run over a little bit there, but
sorry.
that's okay. Any of the questions we haven't got to, we'll get back.